Okay. People are still signing up, but I think we should get going just in the interest. I know we gave time to each of the speakers. So hi, everyone. Welcome to our webinar. Is automated trucking and tethering a key solution to emissions reduction? I'm Michelle Demers, founder and CEO of Boundless Impact Research and Analytics. We have a great lineup of speakers and a very engaging topic to discuss today. I'm going to tell you briefly about our work here at Boundless. You want to just go back a slide. And then introduce our first speaker. First, a couple of housekeeping items. If you'd like to ask a question during this webinar, we have a Q&A portion at the end. You want to do so by typing it into the webinar control panel on the right-hand side of your page. This window can be expanded for better viewing, and we'll be reading these questions after our speakers have presented. Also, keep an eye out for our next webinar on fungi-based meat substitutes, which will take place on January 20th at 11 a.m. Registration is already happening on our website, so you can go and take a look there. Next. So Boundless is an industry research, next slide, please. Thanks. Boundless is an industry research and impact analytics firm that provides quantitative evidence-based information for investors, companies, and funds. And the fastest growing arm of our business is doing environmental impact assessments on specific products and technologies in the clean tech space. We're unique because we're backed by science. We base our methodology in life cycle assessment. It's very science-based. We carefully select relevant metrics and industry benchmarks for every industry vertical we analyze, and we have industry experts that validate the data of the companies we've assessed. Next. And we're trusted by the investors that also subscribe to our portal. So we share these company reports as well as a lot of other content with a fast-growing network of family offices, private equity investors, and clean tech funds. Please feel free to get in touch with us if you're interested in membership. Next slide. So a lot of noise exists in the ESG space, and unfortunately, too many of the ways that companies are scored and analyzed are based on self-reported and unverified data. And studies have shown that ESG ratings tend to disproportionately favor large and mega cap companies, and they're unfortunately biased against smaller companies. And also GHG emissions that are reported are usually just limited to a company's central operation without accounting for some of the resource intensive activities that are associated with their supply chain activities or their transportation or waste. Next slide. And so it's not surprising that the U.S. Securities and Exchange Commission has recently, or I guess it was last spring, they announced the formation of a task force aimed at ESG misconduct and compliance. And investors are starting to demand more detailed and accurate reporting around environmental performance. Next slide. And so we believe science-based life cycle assessment, which truly looks at all of the different types of data across the entire life cycle of a product and the entire activity of an operation, is really the only way to go. Next slide. And the way that we validate data is using this life cycle analysis-based approach, which enables investors to then decrease exposure to climate-related portfolio risks and gives them the data they need to figure out which technologies really are gonna be the market leaders based on their environmental and market-driven performance. And we're gonna talk more about that later. So let me move to today's topic. So automated trucking increases the efficiency of the transportation of goods, allowing for something like a daily range of 16 to 22 hours of operation for a single truck. It's become the only way we can sort of reliably get goods to the places they need to get. autonomous driving has 5 levels, increasing in autonomy, with level 5 being fully autonomous. But most commercial autonomous trucks operate around level 2, assisted driving, where the driver's still in control. Automated truck tethering, which we're going to learn about today, falls in level 3 and up, and it enables trucks to reduce idling by up to 90% and increase fuel efficiency by 8% on average. So I'm going to introduce our first speaker, Barak Sen, who's served as the independent expert for the assessment we did that we're going to talk about today of locomotion's technology. Barak is currently investigating the sustainability implications of different electromobility and battery technologies at the Sakarya University in Turkey as Marie Curie Tubitak postdoctoral research fellow. And he's going to provide an overview of automated trucking and the state of current landscape. Over to you, Barak.
Thank you very much for having me tonight, and for this great opportunity actually to both appreciate the serious work that Locomotion and Boundless have put into this project, and automated and sustainable automated truck technology. So it's my pleasure to briefly touch upon the sustainable implications of autonomous driving in long-haul transportation. Next slide, please. We can also quickly skip to the next slide. Thank you. So I would like to briefly touch upon the state of the US truck transportation. So not only has the trucking been the dominant mode of moving goods around and across the United States, but it's also projected to be the mode of choice in the future, as we see in the figure. And the data from the Bureau of Transportation Statistics also confirm this, as we see in figure B, showing the number of registered combination trucks by year. And this causes the increasing trend that we see in figure C in fuel consumption, despite a sudden drop due likely to the ongoing global pandemic. Against this drop, though, we see in figure D showing that the upward trend in greenhouse gases emitted from long-haul trucking. So looking at all these figures that are generated from quite plausible data sources, we can say that this quick status check indicates that the demand for goods and their movement has been rising. And this, in turn, raises concerns over overall environmental quality, macroeconomic stability, and energy security. And this is because currently slightly less than 90% of trucks run on diesel, and the majority of this is foreign imports. Next slide, please. So to that end, connected and automated vehicle technology is actually expected to revolutionize the way we move goods and the way we mobilize. This holds for both long and short haul transportation. But I don't mean to sound neo-Malthusian here, but just like every other technology, this connected and automated vehicle technology also comes along with its potential improvements and drawbacks, as well as associated concerns. So if you would like to mention a few potentials that are not limited to the ones that are listed, it's expected that, and also has been shown by this study that Boundless carried out for Locomotion, and also by other studies in the literature, that retrofitting a conventional truck with an automation technology reduces emissions and energy intensity of trucking by 10%. It's even further improved with this technology from Locomotion, and it also provides other environmental improvements, such as reduction in water footprint, as well as health impact costs. In terms of operational costs, this achieved increased fuel economy and optimized driving help decrease these operational costs from fuel and this results in reduction of overall life cycle costs of trucking, actually. And in addition to these savings, it's been also proven that there's optimized driving and connected driving increases the traffic safety, and also this increased connectivity actually, since the transportation sector is quite intertwined with other industries, it also increases connectivity across industries, I can say. Next slide, please. Thank you. Of course, as I said, it has a potential, but it also comes with its drawbacks because it's reliant on, for instance, intelligent transportation system enabled infrastructure. I mean, definitely the technology that we have worked with locomotion is definitely capable of bringing significant improvements in terms of environmental sustainability. What I'm trying to point out here is basically the overall system efficiency, overall increase in system efficiency. If we increase the connectivity, we will need this ITS-enabled infrastructure. And of course, an important aspect of the sustainability of any technology, which is not discussed as much as other aspects, which is the materiality aspect. And we should also keep in mind that this technology will rely on critical materials such as lithium, cobalt, copper, and some rare earth elements like neodymium, indium, and dysprosium. So these are a few drawbacks that came to my mind that are currently investigated as well. And as for the concerns, cybersecurity and network safety is definitely a number one priority. There are adversarial attacks that actually target the navigation capability of automated trucks and vehicles. There are companies. One of them is located in Florida. They are producing invisible signs that can help in these situations. So there are companies thankfully working on this, but this is a very important concern when it comes to technology, and also wider implications of this technology in terms of urban planning and public policy and legal and ethical matters. Like what happens if in the line of a collision, if a crash happens on a highway, how the case should be handled, etc. Next slide, please. Thank you. And of course, there are, we can say, I was assessing this with Brett also, there are different ways of reducing emissions, targeting emission reduction actually. This is at least the case, this is the perceived case in the industry. I wanted to show with this slide is that even though alternative fuels may provide certain improvements to some extent, they may not be enough. So retrofitting a conventional truck certainly improves sustainability significantly. However, the question here is it enough if we consider all the agreements and IPCC reports and the global status of climate change? So this brings us to the right fuel for the right technology, which locomotion is working on. Next slide, please. So if we say, so if we are going to electrify and connect our automated technologies, including trucks, then we will maybe have to redefine our value chain. So, and it will require new value chain infrastructure, including different battery chemistries and their different impacts, their different raw material demands, and then energy infrastructure. Should it be hydrogen infrastructure or electricity infrastructure with solar panels or with wind power, and as well as refueling infrastructure, there's storage capacities and ITS and intelligent communication system infrastructure. And all these come together, come down to our ultimate goal of improving sustainable development goals, achieving them. So it has to be thought of from many different aspects if we want to increase the impact of locomotions and technology and other technologies like locomotions. Next slide, please. And this brings to my final slide. And I was quite inspired by one of the articles that Brett shared in the webinar invitation, and there it was saying on EPA's webpage, actually, businesses can reduce the risks faced globally from air pollution and health effects caused by freight transportation by measuring, benchmarking, and assessing their impacts, basically. And this may sound cliche, but I would like to underline with bold colors that if we want to achieve this, we have to go multidisciplinary, and we have to go multi-stakeholder, and not only for our product design, which is Locomation's automated truck technology in our case, but also its system sustainability, its understanding its impacts from a supply chain perspective, but also for designing our infrastructure for it, designing it and measuring sustainability. With this, I conclude my presentation, and thank you again for this opportunity.
Thank you very much. Now I'd like to introduce our second speakers, Dr. Chetan Merkley and Finch Fulton from Locomation. Chetan Merkley is CEO of Locomation and a commercialization specialist at the National Robotics Engineering Center of Carnegie Mellon's Robotics Institute. And he has over 15 years of experience developing and deploying complex robotic systems for real-world applications. And Finch is Vice President Policy and Strategy for Locomation, having served at the U.S. Department of Transportation from 2017 to 2021. And Chetan and Finch are going to discuss Locomation's innovative technology and how their ARC system differs from traditional autonomous trucking technology. They're also going to explain the environmental benefits of their design and predictions for future applications. Over to you, Chetan and Finch.
Thank you so much, Michelle. I'll say a few introductory words before turning to Finch for the broader discussion here. Thanks for the wonderful introduction. Hi, everyone. It's great to be here with all of you. I'm Chetan Merkley, the co-founder and CEO of Locomation. As Michelle mentioned, we launched Locomation in 2018 to commercialize our deep expertise, decades-long expertise in robotics and AI, and particularly in autonomous vehicles, to revolutionize transportation, starting with long-haul road transport operations. Today, our team consists of world's foremost experts in autonomous vehicles, robotics, artificial intelligence. A majority of our team is from Carnegie Mellon's Robotics Institute, and some of us, including myself and my co-founders, are from National Robotics Engineering Center, which is the applied R&D branch of Robotics Institute. And we have a growing team of trucking industry leaders with deep knowledge and experience in pretty much every aspect of the trucking business. And on a personal level, as a CEO and as a technologist, my goal is to not only innovate technology that improves road transport operations, but also substantially reducing harmful environmental factors in the immediate future. So, of course, we are all in business. We all would like to make money. We are motivated by the financial return, but it's not just that. Having a deep impact in the environmental footprint also is something that I personally deeply care about. And we have to keep in mind that approximately 29% of total US greenhouse gas emissions are related to road transport, and that's massive. The challenges created by the record GHG emissions is reshaping the world around us and demanding a forward-looking strategy for both trucking fleets, both carriers, who are our primary customers, and shippers, whoever has any cargo to ship around. And we deeply believe that Locomation's deep proprietary technology is a big part of the solution in the near future. And at that point, I would like to turn to my colleague Finch for the rest of the presentation. Thank you so much.
Thank you, boss. And if we can flip over to the next slide, please. So as Chetan mentioned, we are an American-based autonomous trucking company that has a realistic plan for deployment that takes an evolutionary approach to the market. So we have a human-led two-truck linked convoy model with 2 human drivers and 2 autonomous trucking systems, which allows operations to be conducted nearly continuously while staying in compliance with today's federal regulations. And you'll see a little bit more about this in the short video we've got coming up. But what you should know is with our approach, you can go twice as far, twice as fast while obeying speed limits, carrying twice as much and generating double the revenue per trip. And because of our human-centric model, we're doing things our competitors aren't doing and can't do. Our business model is really the only one that makes sense for targeting this market and for making the impact to America's transportation system. We can flip over to the next slide. If you look at the industry-wide impacts as a whole and the pressures and the needs of our customers, the carriers, you see that freight demand is increasing. The overall amount of freight, the 72% that travels on trucks each year, and the turnaround rate. People expect shipments quicker, right? With everything going on with e-commerce and work from home and everything like that. But you have a constrained supply. There's a truck driver shortage that's massive in the US, and it's even greater in the EU and in China. And the average truck is only utilized about 30% a day. And if you look at the carbon emissions crisis and what this means for the nation, what's relevant to all of us, you have 25% roughly of greenhouse gas emissions in the US caused by transportation, and over 25% of that caused by the truck transportation. And so as you look at solutions like one we've got that can reduce this by over 20%, these are near-term steps you can take right now to reduce carbon emissions. And I will just say, I kind of disagree with the previous speaker. Not every autonomous vehicle has to be electric or have alternative fuels, but when you do it right, automation can incentivize the adoption of these things. So we don't have to worry about cobalt or anything like that. We can deploy with today's technology. If you can go to the next slide, we'll show a little bit more about how the model works. And if you can start the video on the next slide.
Autonomous trucking is a historic opportunity, and Locomation gives you an entire portfolio of turnkey solutions to grab it. First, our Autonomous Relay Convoy, or ARC technology, allows a human driver to pilot a lead truck, while a follower truck operates in a two-truck convoy through a linked, fully autonomous driving system, allowing the second driver to clock off. By switching leaders intermittently, the convoy can operate continuously up to 22 hours per day. Second, our autonomous relay network helps you identify and select routes that will best meet your customers' needs to maximize efficiency and increase profitability. The information we provide opens up vast new freight opportunities that have been optimized for autonomy. Third, our digital transportation system features a suite of proprietary tools and resources to enable you to efficiently execute your autonomous truck service. At full operational strength, the ARC system will cut annual operating costs by 30%, increase equipment utilization by 130%, and increase driver utilization by 250%. On top of all that, it will eliminate more than 60 metric tons of carbon dioxide per tractor annually and improve the quality of life for drivers by getting them to their home base nightly, improving their safety and their sleep time. If you're ready to start re-engineering your supply chain for autonomy, contact us today to schedule a demonstration. Visit locomation.ai for more information.
All right, I love that video because it shows who we are in 99 seconds or less, and it really helps people understand how the autonomous relay convoy works. So as we pull up this next slide, I think it's worth noting that we are the only autonomous trucking company to have real signed customer contracts, not just reservations or a place in line that can be easily canceled. People are putting money on the line and they're investing in this technology, and we'll be delivering our first trucks to Wilson Logistics this year, by the end of this year. So we'll be on the road, wide-scale deployment about this time next year. So if you can flip over to the slide after that.
Okay, I was just
So
coming
our
on to say
customers
your
are
audio
able to
was.
generate significant profit today and are going to be positioned for greater cost savings tomorrow when the technology and regulations allow it. Federal regulations allow for the driver of a truck to be a human or a machine, but everything else a human truck driver does still has to be done by a human at this point in time. So what we're able to do is get on the road, get the value to the customers today, and learn from this and start developing these efficiencies so that when it comes time to go to removing the driver in a hub-to-hub model and ultimately a dock-to-dock model, we will be ready and we'll have thousands and thousands and millions of miles of real-world experience to be able to help us take advantage of this opportunity. If you can flip to the next slide. So as we get ready to take advantage of this opportunity in front of us, to deploy at scale in a year and to take advantage of this $800 billion opportunity, we have to make sure we're doing it right. The policy implications are massive, right? And so you'll hear more about how the ARC technology can drive a reduction of 22% in CO2 per year per truck, which is a big deal. But also, as we look at the impact to the labor markets, as we look at what it means to the human capital and the drivers, no truck driver that's a driver today should worry about losing their job. And the truck drivers of tomorrow will be able to take advantage of a different type of job and to be able to use technology for them, not instead of them. And we've written all sorts of reasons why that is, and the U.S. Department of Transportation has done independent research that validates that. And as we look at how we approach safety, we're going to be able to make massive differences in on-road safety. There's 5,000 deaths on American roadways every year that involve a combination truck. We can start improving the safety of the truck operations and ultimately the safety of the roadways as a whole. If you can go to the next slide. So as we look at all the overall impacts that we can drive, as we look to move forward, we're going to be the first autonomous trucking company to safely, legally, and routinely engage in commercial operations at scale across the United States. So we're going to be able to bring this reduction in greenhouse gas emissions. We're going to be able to decrease fuel consumption by 21% per truck. We're going to be able to lower the photochemical ozone formation by 22%. We're going to cut the operating cost by 19%. And we do this with that back-end organizational approach by making sure you can make life better of the drivers and by making sure you can take advantage of the technology and the organizational aspects that merge together to bring new possibilities for how you can be more efficient and effective in your operations. So we're going to be successful not because it's good policy outcomes. We're going to be successful because the policy outcomes line up with the economic incentives for carriers and shippers to adopt our technology. And really, this third-party validation by Boundless really helps us emphasize this to the carriers so that they know that it's not just us blowing hot air. We're going to be able to prove it with independent third parties, and we're going to be able to prove it on the roads this time next year. Well, we'll have many pilots leading to that, but the first commercial deployments this time next year, which is something very exciting and something no one else can do. So thank you very much for the time to talk. I'll hang on the line so we can answer any questions at the end.
Thank you, Finch, and thank you, Chetan. That was great. I'm sure people have questions, but if you could please hold them. You can type them into the box on the webinar control panel on the right-hand side of your page. And I'm going to be reading these questions after our initial discussion. So now we're going to turn to our impact assessment of Locomation. And just a couple words about our impact assessment method. We abide by life cycle assessment as kind of the foundation of our methodology. Brett's going to walk you through it. Brett is our Director of Research for Boundless. He has a wealth of experience in life cycle assessment. And Brett's going to discuss Locomation's, our assessment of their technology, explaining how we did the analysis, as well as go into some details around the environmental performance of their technology and how they compare to other heavy technology interventions in the trucking sector. And in that comparative analysis, we learned some very interesting insights. So I'm going to hand it over to you, Brett. Thanks.
Great, thank you, Michelle. So we go to the first slide. Excellent. So just to introduce the audience to the approach that Boundless took in performing this assessment, I first wanted to open up with the functional unit that we use to compare different trucking technology interventions. So while the average person is familiar with miles per gallon as a metric for efficiency of vehicles, especially passenger vehicles, the real most meaningful metric for the trucking sector is the ton kilometer or ton mile, if you want to use those units. Because the ton kilometer represents the service that the freight trucking industry provides to our economy, really measuring how you move an increment of goods incrementally closer from suppliers to consumers. So this functional unit of a ton kilometer enables apples to apples comparison of different trucking technologies across different operating scenarios, and will normalize for the payload on the truck. It will account for how much empty miles the truck is driving, fuel wasted during idling operations, etc. And then the key metrics we looked at in this assessment include the greenhouse gas, aka carbon footprint, the operating costs, which is important to the bottom line of any potential customer, the greenhouse gas abatement cost, effectively the price you'd need to pay to get the technology at cost parity given a certain price on carbon, the energy footprint, and the air pollution. For air pollution, we use ground level or photochemical ozone as the most important metric for this sector. We go to the next slide. So for those not familiar with the terms Scope 1, Scope 2, and Scope 3 emissions, I'll just quickly go over them. So Scope 1 emissions are direct emissions from sources that are owned or controlled by a company. So the most common example of Scope 1 emissions would be a smokestack at a factory. But for vehicle fleet operators, the emissions coming out of the vehicle tailpipe would count as Scope 1 emissions. So that would be the majority of emissions from vehicle fleet owners. Scope 2 emissions would account for indirect emissions from generation of purchased energy, such as electricity, heat, and steam. Not so much of that in the trucking sector. And Scope 3 emissions would account for emissions not owned or directly controlled by the company, but would relate to its activities either upstream or downstream through the supply chain. So in the trucking sector, the manufacturing of the truck and tires would be considered Scope 3 emissions. Petroleum refining would be considered Scope 3 emissions. Even roadway repair would be considered Scope 3 emissions. But that's something we did not include in this assessment because roadway repair was not seen as something where locomation would have much of a dent relative to its competition. The wheel or the pie chart shown here is specifically for locomation's carbon footprint, but the proportional makeup of the footprint is pretty comparable across the different options that we looked at for trucking. So the majority of the emissions, not surprising, come from vehicle operations, so the combustion of fuel in the engine and the emissions that come out of the tailpipe. But about a quarter of the emissions are considered Scope 3, so vehicle manufacturing, fuel refining. So I'll show the relative performance of a truck outfitted with locomation's equipment compared to conventional trucks and two other technology interventions that we looked at. So next slide, please. So here the four bar graphs, the four bars in this chart indicate conventional trucks, so without a technology retrofit, a truck equipped with cooperative adaptive cruise control, a truck equipped with idling reduction technology, and all the way on the right is a truck equipped with locomation's autonomous relay convoy system. So in our analysis, we found that given the data provided by locomation, they can reduce the greenhouse gas footprint of Class 8 trucking per ton kilometer by 22%, which is a pretty significant reduction. So I'll point out here that if we were only looking at miles per gallon, we would only expect to see around an 8% improvement, and that is largely due to the efficiency in roadway operations where the vehicles can follow closely to each other, reduce drag. But an incredible amount of locomation's benefits come from the fact that the vehicles are on the road, 20 some hours a day. So you're cutting out a lot of the idling activities that the majority of trucks on the road would have these days, and that's just wasting fuel while trucks are sitting still. And also the locomation's routing improvements, which were mentioned in that video, also account for a pretty significant increase in efficiency, where you're not moving empty trucks around the highway and burning fuel. The trucks are full a much higher percent of the time. All right, let's go to the next slide. So next, for the business owners out there, looking at the operating costs is a pretty important consideration. So for the operating costs across the different alternatives we looked at, we include the cost of the fuel, which is big, but also the cost of the labor, so the truck drivers, truck maintenance, insurance, etc. And for the three technology retrofits, we included equipment and labor costs of installation, operations and maintenance implications, and any subscription costs if applicable. So we see, even though locomation does have a price tag associated with bolting it onto an existing truck, and then there's some costs associated with the subscription model, effectively, where you keep it on truck. The cost savings far outweigh the projected cost of adding it to a truck. So looking at the other two technology retrofits, adaptive cruise control and idling reduction technology, they both had a pretty small impact on costs. So you can see that the idling reduction technology does still come with a cost benefit over conventional trucking, whereas the adaptive cruise control appears to drive costs up ever so slightly. Go to the next slide. So here, this is a kind of a convergent metric where we look at the greenhouse gas abatement cost, which is effectively the premium that one could attribute to carbon savings associated with the technology. So that the premium per functional unit divided by the reduction in greenhouse gas emissions, so tons of CO2 saved. So, some of you may have seen these charts that look kind of like a set of stairs that McKinsey is famous for producing, but other institutions have released them as well. Effectively, if you have a negative number, that means that your technology is cost effective even without a price on carbon or even without a mandate to reduce carbon emissions. So here we see that Locomation, given the projections, would come out very attractive from in terms of a cost-effective means to reduce carbon emissions, where it would effectively pay for itself $680 per ton of CO2 avoided, whereas the cooperative adaptive cruise control on its own is expected to not necessarily be cost-effective unless there's some kind of policy subsidy or carbon market that would really put a price on those carbon savings. And the idle reduction technology, the benefits weren't as significant as the Locomation package, but still appears to be cost effective. You can go to the next slide. So I did want to spend a little time on a metric other than cost and carbon, as those seem to get all the attention in the headlines these days. So photochemical oxygen, photochemical ozone formation is a very important public health concern. So it was especially bad in Los Angeles, Las Vegas, and increasingly in cities around the world where there's not a lot of airflow and you have a lot of emissions from industry, from vehicles. So it's ground level ozone is a respiratory irritant that can aggravate folks with asthma, the elderly, etc. So while Locomation and these other technologies are not anticipated to have a major impact on how the engine actually operates, just the fact that they're reducing fuel combustion and fuel consumption is expected to lead to significant reductions in the precursors to ground level ozone, mainly volatile organic compounds and nitrogen oxides. So by reducing the fuel consumption of trucks, there's expected to be a benefit for all three technology retrofits that we looked at, most significant, as you can see, with Locomation on the right there. So we go to the final slide that I have here. So this is the slide that summarizes everything that we looked at. So Locomation on the Boundless score scored a 10 out of 10, which is a pretty impressive total tally. So a lot of that is attributed to the sheer scale of Locomation's ability to reduce emissions and to reduce costs. So they outperform the other technology interventions pretty significantly. I don't want to take too much away from those other interventions. They're a smaller scale, but still worthwhile, especially on potentially older trucks that don't have the ability to adopt a Locomation system. It's still worth looking at those. So I don't want to say that those aren't looking at. And then there is some synergies as well with the cooperative adaptive cruise control and the Locomation system as well. So folks can learn about that more if they're interested. So yeah, just for the time being, I think it's important for folks to know that while there is a lot of movement in alternative fuels and alternative propulsion systems coming out for passenger and freight vehicles, the existing fleet of trucks is going to be around for years. So while there's a lot of diesel trucks out there, it makes sense to adopt a lot of these bolt-on interventions. And Locomation, given the numbers that we looked at, seems to have a very compelling offering. So that's all I have.
Brett.
I appreciate your time. Thanks, Michelle.
That's great. Thank you, Brett. That was really great. So we're going to move to the Q&A, and I want to remind the audience again, we've gotten a couple questions in, but please don't forget, if you have questions, you can type them into the box in the webinar control panel, which is on the right-hand side of your page. And to get started, I'm going to actually start with a question or two of my own. Chetan and Finch and Barack too, would love to hear you weigh in on this, but why is autonomous trucking not the norm yet? This seems like an absolute no-brainer to me.
Well, I can say that certainly Chetan only started the company 3 years ago. He probably should have started sooner. But really, it's about the technology coming together, the convergence of different capabilities coming together, and then the market. Because what you saw is, once people started to figure out how they could make the technology work, they started going after light duty vehicles, probably because it's more tangible and accessible. And it's really only when you started to see a pivot to trucking as the first use case, because of the simplicity of how it's deployed and because of the business case behind it. It's got roughly 10 times the size of the market as passenger vehicles. That's really when you saw just an outpouring of funding and attention and effort and research going into that area. The technology is not completely there yet. Certainly, we're going to be one of the first. But as you look at some of the major capabilities, even some of our competitors that are showing that they can now do a run on one road at one time with drivers out,
Right.
they're still not ready to do a production grade vehicle at scale where you can fully remove the driver. Some issues have to do with steering systems that have to be redundant, braking systems have to be redundant, the throttling systems. So those technological capabilities will probably be ready for production grade. I'm going to say 2025, 2026, maybe sooner if a company comes out with their own unique answer. But certainly when you simplify the problem like we have, it allows you to have the technology address the issues while being able to get on-road results that can lead you to handle some of that, the final, 20% takes 80% of the effort. So we're going to be able to be generating revenue and insights as we tackle that final 20%, where some of our competitors are looking to start out by figuring out the final 20%. So I think probably the real question is, how long is it going to take for people to try and mimic our model?
Mm-hmm. Right. Okay. Barack, do you have anything you want to add to that?
I will agree with Mr. Fulton on the fact that even though the efforts actually started with the implementation of this technology in light-duty vehicles, especially passenger vehicles, it seems like technology developers and the industry saw the benefit and simplicity. I agree with this completely, of implementing this technology in this particular domain. And not only because it's simple in the way that it can be deployed, but also it is related to the sustainability implications of trucking itself and the projections that the panelists actually all presented.
Mm-hmm.
And I will say, so the reason why it's probably not there today, I mentioned the technological reasons, but certainly, and I talked about this when I was going, the federal regulations about the other things a driver has to do in the operation of a vehicle, inspection, maintenance, repair, how you deal with law enforcement, how you deal if someone else crashes into you. The federal regulations essentially don't allow for you to remove the human driver. So the business case for other models won't be there until probably 2025, 2026, could be longer before the federal government updates all of those regulations. And these are regulations that I helped start when I was at USDOT. So those have to be finished completely, and that takes time.
Right. And if alternative fuel or electric trucks start to become popular, are they going to be more or less attractive candidates for automation?
So what we're seeing is, many autonomous trucking companies are platform agnostic. I don't have a study that shows this, but some of the backhand math that my staff at DOT came up with in their discussions with the Department of Energy and EPA shows that, they don't expect, the federal government doesn't expect for there to be an economically viable option for, let's say, electrification of long haul operations until the end of the decade, 2030, 2032, because of things like the durability of the battery, the amount of time it takes to charge the battery, how many times you can recharge the battery, how many years the batteries will be good. And then you also have secondary issues around the supply chain. And I do agree, if you're talking about electrification, issue with how you get the rare earth minerals that you need to be able to make the systems work, and then issues with how you dispose them at the end of life. So these are things that we have to work through. Certainly with the infrastructure bill, we're going to have lots of and billions of dollars in federal funding to help with those efforts. But it's one thing to say that, you know, it would be nice if these were electrified. It's another thing to say the technology is ready today. But we do see lots of areas where, because autonomous vehicles need additional power, you know, electrification and the batteries, more utilization of the batteries, that does provide greater incentives for the adoption. So while we're looking at deploying with today's vehicle technology, certainly we're looking and talking to strategic partners that can help with the electrification of the fleet or with the adoption of alternative fuels going forward, because it helps drive the story and the business case and the reduction in emissions. So, you know, it shouldn't be a mandate that every autonomous vehicle should be electric, but it certainly seems like that's where the market's going to go. And when it's ready, that's going to be the dominant force in the market.
Right. Barack, do you have anything you want to add?
I would just like to add that definitely it is right now. I will agree again with Mr. Fulton on the fact that there are certain issues regarding the existing battery technologies, commercially available battery technologies. There are quite promising battery technologies that may actually provide the power that is in one charge that is needed to carry the goods across the United States. And we have to work on it, absolutely. But of course, this doesn't mean that, as Mr. Fulton also stated, that companies, especially companies like Locomation, should seriously consider it, as they do, as we see here, the future of the fuel requirements. Because 20% reductions, 30% reductions are good reductions, but as the world just recently discussed, it may not be enough, and we may eventually have to transition to much more sustainable and much more environmentally strong alternative fuels, I would say. Thank you.
I'm going to go to some audience questions now. One of the audience questions is, how do insurance carriers view the risk of relay convoys?
Yeah, I can start. And Chetan, I know that you've been talking to Aon, our insurance provider, for longer than I have. But the question about how do you insure an autonomous vehicle or our system is not necessarily new. And regardless of any headlines or not, these vehicles have been in crashes. In the vast majority of cases, it's other vehicles crashing into these vehicles. I know Waymo got headlines. You saw a headline in 2018, Waymo vehicle involved in crash, and it was a garbage truck in an alley that literally backed into the Waymo vehicle. And this is a perfectly good point in time to say that Teslas are not autonomous vehicles. They're driver assist vehicles, and we should never let anybody confuse them. Despite their own self-branding, they are not autonomous vehicles. But when you talk to responsible autonomous vehicle makers, and when you talk to the insurers, there is, it's not difficult to figure out how to insure them. And, most states require $5 million in insurance. So there's not really a whole lot of difficult questions if you go through the steps to prove the safety case for how you intend to deploy, which we're using the leading industry developed standards for this, UL 4600, ISO 26262, the safety of the intended operational function, SOTIF. So these are some of the ways that we're developing our system to prove to ourselves, to prove to our insurers, to prove to our regulators, and ultimately to be able to prove to the public and tell the story to the public that we're going to be deploying safely. And so we're in the process of that now. We hope to release our voluntary self-safety assessment sometime this summer, but we want to do the work first to prove it and not make it an aspirational document that says, well, this is what we intend to do. We want this to be a real document that people understand, that shows how we've proven we've deployed safely by the time we get there, which again is going to be this year. So they've got lots of exciting work coming up. But in doing that, that's how you make sure the insurers are comfortable with you. But it's not actually a big problem for us. Insurers are pretty comfortable with our approach as long as we follow through the safety steps we've laid out for how we get to where we are today to full deployment.
Right. Okay.
Just a very quick addition on that. Yeah, that's a excellent explanation of how we are approaching this. Another advantage of our particular convoy model with a human driver still in the loop is that you are not leaving the comfort zone of how insurance operates today all that much. There is still a vehicle, a collection of vehicles, an entity, and there is still a driver. So we anticipate, while the details are TBD, and we are working with our insurance partner Aon and several underwriters in determining how this will actually pan out. The broader strokes are going to be somewhat similar to how the commercial vehicle insurance works today, with a little bit more details around how the product liability will be handled, and over time shift from claims-based insurance to data and facts-based insurance.
Thank you. That's helpful. I think we addressed this question, but maybe not. It's for Chetan. When will EV technology be ready for long-haul trucking?
Not anytime soon. So while the idea of having completely electrified trucking solutions is very appealing, we all would love to have that. What's very important for long-haul trucking viability is the duty cycle of the vehicles. For the proper return on investment and proper operational characteristics, these trucks will have to be able to operate for about 22 hours a day. And that only leaves a couple of hours per day for refueling or recharging. And today, the energy density, the weight considerations, and the overall time that's required for charging the trucks don't allow them to be operational on the long-haul routes. Plus, charging a semi-truck that is supposed to hold 80,000 pounds, it requires a significantly higher energy density, and that taps into the infrastructure problems that was brought up earlier. So everything has to line up, and real world has a lot of inertia, and there is still a significant part of the scientific problems here that we don't have answers for. So it's not gonna be soon.
Okay, there's another question here that's probably, Chetan, would be good for you as well, about kind of from an investor here, about competition and the enormous amount of capital that's been raised with direct competitors as well as adjacent verticals. But I'm not exactly clear what the question is. If the person could sort of clarify what their question is. But I do think it would be helpful for the audience to hear about sort of the competition and sort of help them understand, you know, sort of how to justify all the capital that's been raised for this.
Right. So let me, I think I can anticipate the underlying question there, and let me take a swing at it. There are several peers, our competitors, who have raised a couple of billions of dollars, and they also have spent a couple of billions of dollars, and they still don't have a product. So if capital was the answer, we would have had self-driving vehicles by now. There are several peers who are employing thousands of engineers. If the number of engineers were the answer, we would have had self-driving vehicles at scale in commercial operations by now, because it's been over a decade since the private industry has been going after self-driving vehicles. What we believe is the key to success for at-scale, commercially relevant deployment of self-driving vehicles, self-driving trucks, is who can learn faster about the variability and the unknown parts of the real world. And we believe Locomation's approach, starting with the convoys, using the convoys to start deliver value, start generate revenue, and start collecting relevant data at a scale that is several orders of magnitude more than our peers, is the key differentiator that puts us in the pole position for not just deploying earlier, but also scaling our operations faster and extending the capabilities of our technology faster.
Right. Okay, got it. And I hope that answered your question for the person in the audience. I'm going to ask another question, and if they want to clarify anything that they didn't get, they can send me a note. Brett, what were some surprising results of the assessment that people would not normally think about when using tethering technology?
The biggest surprise that I encountered early on was, one, it's disappointing how many idling hours the average truck is still putting on every year. So more than 1,000 hours a year is typical for these Class 8 trucks. And I just want to point out that the trucks are built to be moving and moving goods on the highway, and they're not, it's not providing much value to the economy to be sitting in a rest station idling for 8 hours a day. So what was pretty compelling with what Locomation and potentially other autonomous trucking systems is that they can get these trucks and the drivers on the road resting, but by adding value during that time. So moving 8 hours a day with 20 tons of goods in the back, as opposed to just sitting still. And the you can understand the cost benefits of that are incredible, but also the fuel savings and emissions associated benefits are pretty impressive as well.
Right. Yeah. Yeah, I think so too. So we have to finish up because we're 1 minute before 3 and we got to get this done. But I think everyone hopefully has been able to learn about this. These are incredibly important area of development, and the science around the assessment, I think, starts to reveal why some of the innovations like automated trucking tethering are so important. There's got to be more creative thinking around how we're going to do emission savings, and technologies like this that are answering the question of both creating much better efficiencies for the industry generally, but also address major climate concerns, I think are super promising technologies. So it'll be exciting to see how Locomation develops. Thank you all for your time. Thank you to the speakers. You all did a terrific job, and we're grateful for your time and effort. For the audience, please know that you can go onto our website to learn more about our work, as well as information about our products and services. And also, don't forget, keep an eye out for our next webinar on fungi-derived meat substitutes on January 20th. And again, thanks again to our speakers. Have a great day, everyone.